Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the isometric projections of the combination of the solids. In this problem statement, we have a cone of base diameter 50 mm and height 40 mm, which is placed centrally on top face of a square slab of side 80 mm and height 20 mm. So we need to draw the isometric projections of the combination of these solids. So here we need to interpret two things, that is the types of solids and also the positioning of the solids. So here we have a cone whose base diameter is 50 mm and is having a height of 40 mm. So by default it will be a right circular cone. And next solid is a square slab, and this is having the edge length of 80 mm and the height of 20 mm. So these are the two solids. How they are placed? So we need to understand here it is a cone which is placed centrally on top face of a square slab. That means the square slab is resting on the ground, and on top of this square slab we need to place the cone. And also the most important thing to be noticed here is the center of this cone and also the center of the square slab are collinear. So that is what is meaning of the term centrally on top of the square slab. So with this data, let us see how to do the isometric projections of the combination of these solids. So before we start with the isometric projection, let us draw the orthographic projections of these combination of the solids. So let us select a line of thickness 0.18 mm and draw the reference line of any arbitrary length. Now let us select a line of thickness 0.50. So since the top view of the square slab will be a square itself, so we will draw the square whose dimensions are 80 cross 80. So this is the top view of the square prism. So we'll just place this XY line here. So now we have got a square which is measuring 80 cross 80. So next we need to place the cone. So the cone is sitting on the center of this square slab. Circle option and ensure the thickness is 0.50, and just move the cursor over any two edges of the square so that you get the center point of the square. And from here you can draw the top view of the cone, which is nothing but a circle of diameter 50 mm. So this is the top view of the combination of the solids. So let me select the line option, select a line of thickness 0.13 mm, draw the horizontal diameter of the cone base and draw the projections and intersect the XY line. Similarly, draw the projection line from the center of both the solids and ensure the projection line is making a perfect 90 degrees. Also draw the projections from the corners of the square slab. So from here we need to draw the center line of the solids. So let me just change the line type to center, and the thickness of the square slab is 20. So let me draw a line of 20 mm, and from here I need to draw the height of the cone, and the height of the cone is 40 mm. So this is the center line of both the solids. So you can just see that they're not collinear. So just select the move option and place the line on this endpoint. Okay. So now we will complete the front view. Select a line of thickness 0.50 mm. Ensure it is a continuous line. So from here, draw the front view of the square slab, that is 20 cross 80. Next, from here, let me draw the projection or extend the projection lines of this cone. So I've extended the projection lines. Now let me select the line option. So from the apex of the cone, let me join this to the end points of the base of the cone. So these are the slant generators of the cone. So this completes the front view of the combination of the solids. So go for the smart dimension, show the thickness of the square slab and the height of the cone, which is equal to 40 mm. And here in the top view, you can show the diameter of the base of the cone, which is equal to 50 mm. So these are the orthographic projections of the combination of the solids. So go for the text in the annotation and let us annotate the reference line as x and y and also the reference planes as VP and HP. So this part is completed now. So now we'll go for constructing the isometric projection. Select a line of thickness 0.13 mm. Draw a line of any arbitrary length. So this forms the baseline. So on this baseline, we need to place the square slab. So select a line of thickness 0.50 and draw a line of length 80 mm, incline at an angle of 30 degrees. So in the ISO sheet, you'll be directly selecting 8 boxes. But here, draw it using the 2 dimensions and later on convert it to the ISO scale. Height of the square slab is 20 mm. So draw a line of length 20 mm in the isometric sheet. It must be 2 boxes from that edge of the from that corner of the square. So now 80, the angle is 30. Complete this. Similarly, from this corner, line of length 80 mm and the angle is 150 degrees. So complete this. Next again, 80 minus 150, complete this. And then you get the square slab. So, but however, these edges are not visible to the observer, so I'm going to change the dimension to 0.13 mm. So this is how the square slab is going to look in the orthographic projection, sorry, the isometric projection. So now let us draw the cone. So let me select a line of thickness 0.13, select blue color line. Let me enclose this base circle of the cone inside a square of dimension 50 cross 50 because the diameter is 50. So now I've completed the square. So now I need to construct this square. So for that, let me join the diagonals of this square slab so that I get the center point. So from the center point, let me mark a line of length 25, that is half of 50. And again, here, let me draw a line of length 25 at an angle of minus 30 degrees. Similarly, here, 25 and the angle is 150. Correct. So let me complete the square now. So here it is 25, the angle is 30. So from here, draw a line of length 50 mm and the angle is minus 30. From here again, line of length 50 mm, angle is minus 150. Again, the length of the line is 50 and the angle is 150. And then complete this 25 and my plus 30. So you get this. So we can just trim this to avoid the confusions. Let us just keep this particular square only. So let me just split this. And change the color of this line which is forming the edge of the square slab. So this is fine. So now let me construct the circle by using the 4-point center method. Select the line. So this is the corner point. So from here, join the midpoint of the opposite edges. Always ensure the midpoint is on in the IntelliSketch. So this from this corner, join this midpoints, and this is the diagonal of the square. So this is C3 and C4, C1 and C2. So now let me go for a line of color black and thickness 0.50 mm, and I'll be selecting arc by center point. So with C1 as the center and the arc length being equal to this dimension, cut an arc. So next again with C2 as the center and the arc length being this, draw an arc. And then C3 is this point of intersection. Sweep an arc of this radii. So always ensure you're going to select the point of intersection because there will be center point or the midpoint and then the end points. So always ensure that it is the point of intersection. So this completes the base circle of the cone. So from here, I need to draw the axis of the cone. So let me again go for the blue color itself. So the axis of the cone is measuring 50 mm, correct? So let me change the thickness to 0.13. Now let me select the line of thickness 0.50. So this is the apex of the cone. So just draw the line as if it is a tangent to the arc here. Do not join this to the end point. So always that precaution has to be taken whenever you're constructing the cone. So this is the tangent. So you got to see the tangent symbol, correct? So that is where you have to stop. So this completes the construction of the cone. So now we have to separate this part of the line and make it a invisible line. So use the split option. So now you can just see that these two edge lines are selected individually. I'll change the thickness to 0.13, and also I'll select the split option again, select this entire arc and then split the arc at this point, and similarly select this arc and split the arc at this point. Now let me select this arc and this arc and this arc, change their thickness to 0.13 mm. So this completes the construction of the cone on the square slab, and they are resting centrally on each other, correct? So let me show the angle. So this is 30 degrees, this is 30 degrees. So now let me select the entire combination of the solids, that is the cone and the square slab, and change the scale to 0.816. 0.816. Ensure the copy is off and drag and paste it at the same point. So now you get the isometric view of the combination of the solids. So go for the smart dimension. So 20 is reduced to 0.816, that is 16.32. Unlock this and overwrite the dimension as 20. So this is ISO 20. Similarly, here it is 65.28, that is 0.816 times 80, correct? So unlock this and change this to ISO 80. And again, select distance between the apex of the cone and the center point of the base circle of the cone. So this is equal to 40.8, so which is 0.816, the height which is equal to 50 mm, correct? So now let me just rewrite this to 50. Okay, this is 40, not 50. So let me just rewrite this to 40. So with this, we complete the isometric projection of the combination of the solids, wherein a cone is being placed centrally on top of a square slab which is measuring 80 cross 20, and the base diameter of the cone is 50 mm and the height of the cone is 40 mm. So with this, we complete the orthographic projection of the combination of the solids and the corresponding isometric projection also. Thank you all for watching.